This question says two long parallel wire separated by 5.0 millimeter each carries a current of 60 amp. These two currents are oppositely directed. What is the magnitude of the magnetic field at the point that is between the two wires and 2 millimeter from one of the two wires? Assuming I have the first wire, and this is one, and this is the second wire. Let's say this is one, and here is two, and the distance between the two wires, the distance is 5 millimeter. So, and the direction of the current, okay, each of them carries the current of 60 amp, is 60 amp. I is equal to this, and I is equal to 60 ampere. And let's assume this is flowing down and this is flowing up. So, we're asked to calculate the magnetic field at the point where, let's say this point will be 2 millimeters. The distance from here, the distance from this side is 2 millimeters, and the distance from this side is 3 millimeters. So, and using the Biot-Savart law, we have B to be equal to mu naught I divided by 2 pi r. And for the first magnetic field, we'll be having this to be 4 pi times 10 to the power minus 7 multiplied by 60 divided by 2 pi multiplied by, here it's given in millimeters, so if we divide this is R1, let's say R1 is 2 millimeters, and this is equal to 0.002 in meters, and R2 is 3 millimeters, which is equal to 0.003 meters. So multiply by 0.002, and when we multiply this, okay, this can cancel. We'll be having this to be 2 times 10 to the power minus 7 multiplied by 60 divided by 0.002. And if we simplify this, we'll be having this to be equal to 2 by 60, this is 120 multiplied by 10 to the power minus 7, and this is 123, 2 times 10 to the power minus 3, and this will be equal to 120 divided by 2 multiplied by 10 to the power minus 7 plus 3, and this is equal to 60 times 10 to the power minus 4, and we have this to be 6 times 10 to the power minus 3, and this is in Tesla. So, but we can as well convert it to 6 times 10 or 6 millitesla. 6 millitesla. Millitesla. So this for B1, and let's calculate the one of B2. I have that the B2 will be equal to mu naught I divided by 2 pi r2. This is equal to 4 pi times 10 to the power minus 7 multiplied by 60, which is the current, divided by 2 pi multiplied by the R2. We determine it as determine it to be 0.003, and if I plug in the 0.003 in the 0.003, I'll be having 2 pi can cancel, then we're left with 2. This will be equal to 2 multiplied by this is same thing as 120 times 10 to the power minus 7 divided by, we are left with this, which is same thing as 3 times 10 to the power minus 3. And if we simplify this, we'll be having that the B2 will be equal to 120 divided by 3 multiplied by 10 to the power minus 7 plus 3. Then 120 divided by 3 will be 40. 12 4 times 10 to the power minus 4. And this is same thing as 4 times 10 to the power minus 3, which is same thing as 4 millitesla. And we've gotten the B1 to be 6 millitesla. So let's solve the net magnetic field. So the net magnetic field will be giving us B net will be equal to B1 plus B2, and this is equal to B1 is 6 millitesla plus B2 is 4 millitesla, and this will be equal to 6 plus 4 is 10 millitesla. So this is the final answer. Going back to the option, we can see the option B is the right one.